MacMaths. Let's do some maths today. AS Mechanics. Okay, guys, this is only watch this if you are doing exercise 9E from the Pearson book. Okay, so you're doing that and watch this. My class. Okay, I've done a lesson on the vertical motion, and all I'm going to do is go through some questions with you. What I'm going to do is I'm going to go through mainly the odd questions first. So I'm just going to do odd numbers 1, 3, 5, 7, 9, 11. I'm also going to do 12 because 12 is an awkward one. 13 is a bit awkward as well, I think, looking at it. And it's an odd number, so I could do 13 as well. We'll see how time goes on. I don't want to make it too long. So I'm just going to go through those questions. So here we go. Let's get straight into them now. For each one, I want you to draw a diagram, which includes all of you. Okay, you're really bad at drawing diagrams, okay, because you think it saves time, but it's much easier when you draw a diagram. So let's go through number one. Number one is a cliff diver. Okay, so there's the cliff, and it tells you that the cliff is 28 meters. So I'm just going to do these. There's not a lot to add to them actually. And he jumps off, so u is equal to 0 meters per second. The last one. Right, I'm going to stop putting units on because that's just going to be slowing me down. Okay, and he jumps off and he hits the thing, and you've got to work out the time for the diver to hit the water and the speed when the diver hits the water. So that's v, the velocity at this point. Okay, so we want t at that point and the velocity at this point. This is one of those questions that, because you're going that way, you can have, it's the unusual situation, so have down as positive. So that makes that point 28 meters at the bottom, not minus 28 if we were going up. So that's 28 meters. That direction is positive, so acceleration is a positive 9.8 meters per second squared. We don't normally have that, so everything is positive then. So that way is our positive direction. I'm not going to spend as long as this, on the other ones. So let's do it then. First of all, the time. So to find the time, s equals ut plus a half a t squared. We're going to use that. The s is 28 meters. Initial velocity is 0. That's nice because it cancels that out. So that's 0. Half of a, so that's going to be 4.9 t squared. So we've got 28 divided by 4.9 is equal to t squared. So the square root of that. And that gives us a t value of 2.4. Okay, seconds. So that's how long it takes to go down. And you've also got to work out the velocity. And again, so we're not using a rounded off, you can go v squared equals u squared plus 2as. So the velocity squared is equal to u squared, which is 0 plus 2 times 9.8 times 28. Okay, so work that out and square root it to get your velocity. Okay. Yeah, I think I'm just going to move on. You can work that out. Number 3, so jump into number 3. Number 3 says a ball is thrown vertically downwards from the top of a tower, so same thing. A ball is thrown vertically downwards from the top of the tower with a speed of 18 meters, so 18. We're going to go positive down, it's that way, and find the height of the tower. Hits the ground here, so t is equal to 1.6 seconds when it hits the ground. So we've got to find the height. In other words, we've got to find s, the displacement. Okay, so again, we're just going to use for this one, so the height of tower. I'm just checking my screen to make sure that fits in. Oh yeah, just on the edge there. So that's going to be s. S is equal to ut plus half a t squared. So that's the height of your tower, is going to be 18 times 1.6 initial velocity, which is 18 times the time it takes down here, which is 1.6, plus 4.9, That's a half of that times 1.6 squared. I bet that's, is that fitting in? No, is it? I'll just move that across. So S is equal to 18 times 1.6 plus 4.9 times 1.6 squared. Okay, I'm getting the hang of it now. So work that out, and that's your height of your tower. Okay, so that's 1 and 3 done. Let's have a look at 5. Yeah, don't be watching this if you're just tuned in and you thought, oh, I'll watch this fella's doing a lesson on it. It's not a lesson, it's just going through some questions, and it will be dull as dishwater. Okay, a ball is projected upwards from a point which is 4 meters above the ground with a speed of 18 meters per second. So there's my diagram. There we go. That is 4 meters. Okay, and then remember what you do that. Okay, and that represents it going up and straight down, and U is 18. Now this is a standard question, so that means that down is negative, so up is positive. So the acceleration now is minus 9.8 meters per second squared, because you know down is positive. You must get that in as a minus. This is positive because up is positive, as with most of these. Most of these are about throwing a ball or a stone up into the air. Okay. A ball is projected upwards from a point of 4 meters above the ground. Find, and we've got to find A, the speed of the ball when it is 15 meters above. So V when S equals 15 meters above projection, by the way, not above the floor, projection. And we've got to the speed the ball hits the ground, and B, V when hits ground. So that's what you've got to do. Okay, so be careful with this question, because it might say when it's 15 meters above the ground. So you would then do it when S is 11 meters, wouldn't you? Okay. So, because when S is 11 meters from that point there, this is S equals 0, that is minus 4. So this one here, number 5, what are we going to do? The velocity when S is 15. So if we go V squared is equal to U squared plus 2AS, so we're going to go V squared is equal to 18 squared plus 2 times minus 9.8, okay, times, we want it when it's 15 meters above the point of projection. So that is what you're going to do. I'll just do this one for you. So all of that typed in would be 18 squared minus 2 times 9.8 times 15. I've got my minus in, and it's 30. So V is equal to the square root of 30 meters per second to the minus 1. V when it hits the ground, okay, so you're doing V squared equals U squared plus 2AS again to find the velocity when it hits the ground. So you're going V squared is equal to 18 squared. And doing it the same as here, the only thing is for S you're putting in minus 4, because S is minus 4 at this point. So you find out the velocity there. So you're just doing plus 2 times minus 9.8 times minus 4. Now this time you've got a minus times a minus, which is a positive. So that would be 18 squared plus 2 4s are 8. 8 times 9.8, quick way of doing it, is equal to 402.4, and square root that, and that gives you answer. So the velocity is 20.1 meters per second. Okay, and yeah, you get a plus or minus, remember, answer to that when you square root it, and it's the minus that you want because it's the minus going down, but you don't put that into your answer there. So that's number 5. Okay, so we're using S as minus 4 there, and S is 15. Okay, up here to get the velocity at this point. And again, you're going to have that velocity going up and that velocity minus root 30, you know, when it's coming down at that. So that is question 5. So question 7, I've done these at the side, so didn't look at that one there. So question 7, let's have a look at that from the book. A particle is projected vertically upwards from a point X. Okay, so this is the point X. 5 seconds later, it's moving with a downward speed of 10 meters per second. Find the speed of projection and the greatest height above X it is projected. Okay, so I don't know whether it's on a platform or not, but anyway. So it's gonna, there it is. Okay, and it's projected from X. From X, and 5 seconds later. So after 5 seconds, it's going down. So this is, let's say that point is 5 seconds, and it says it's going down. So let's just say it's gone up and it's come down, and it's come down to there. Okay, so at that point, what is the velocity? The velocity is -10 because it's going down meters per second. That's what it's saying. And that's when t is equal to 5. And it's saying the speed of projection. So it's u that we don't know. And we know the acceleration is -9.8. Okay? Because it's down is negative. So u is going to come out as a positive number because up is positive. So this one's quite simple actually. So part A, was there 2 parts of this? Yes, the greatest height attained above X. So let's do A. Part A, to find u, we just use v equals u plus at because we've got everything. We've got v is -10. The initial velocity we don't know, so keep it as u, -9.8 times 5. Okay, and times 9.8 times 598, 49. That's -49. Take it over to there, becomes plus 49. 49 take away 10 is 39, is equal to u. So it's 39 meters per second to the -1. That's what that must have been. Oh, it's very quick when it was catapulted up. That's u. And you're also asked to find the highest point. Well, that's a very standard question, that point there. Remember, that's when v is equal to 0. Okay, is that what it's asking actually? The greatest, oh no, sorry, it's not asking for the time of the greatest. So it's asking for that distance there. Okay, still the same. V squared equals u squared plus 2as. I was just going to use v equals u plus at, and that would, I'm putting v as 0. That would find the time it takes to get up there. But I'm going to use this one here. V squared is equal to u squared plus 2as. Still the velocity at that point is 0, so that's why it's handy. Now we've got that, so we can do 39 squared plus 2 times -9.8 times s. So there we go. All of that gives you 39 squared minus 19.6s. So 19.6s is equal to 39 squared, so s is equal to 39 squared divided by 19.6. There it is. And if you did that, I haven't worked it out, so should I? 39 squared divided by 19.6 is equal to that. So 77.6. So it reaches 77. It's quite high, that. 0.6 meters, about a 10-story building as well. Okay, rounded off. So that's number 7. Number 9. Let's go through number 9. I've got that one on a different sheet, so I'll just flick through that. I just quickly went through them. Number 12 is the tricky one though. So number 9, let's have a look. A stone is thrown vertically upwards from a point which is 3 meters above the ground. Okay, so 3 meters. And it's vertically upwards, going on, with a speed of 16, so u is equal to 16. Oh, okay, so it's just a straightforward question. So it's just up and down that one to there. You've got to find A, time of flight, standard question. Okay, and B, total distance travelled. Be careful with this one. Total distance travelled. Be careful with that one. We'll have a look at that now. So, time of flight. Okay, so let's have a look at some things in here. What is this point here to reach here? This is when s is equal to -3. Okay, because it's 3. Remember, up is positive, down minus 9.8. Okay, so we're just going to put that into s is equal to ut plus a half at squared. Now s is going to go in as -3, so that is going to be 16t. Half of minus that is minus 4.9 t squared. Everything over to one side and we get 4.9 t squared minus 16 t minus 3 is equal to 0. And there you've got a quadratic. You're going to put that in. You're going to get two values for that when you put that into the the minus b. So minus 16, so 16 plus or minus the square root of b squared, 16 squared minus 4 times a 4.9 times minus 3. So you're going to get a minus, so that's all going to be plus all over 2a, and 2 lots of 4.9 is always 9.8 with those ones there. When you put that in, I'm seeing whether I've worked that out. Yeah, I haven't worked that out. So you can work that out. You'll get the time of flight. You want the positive one for that. Okay, so just do 16 plus. You don't do 16 minus because this will be more than 16. So do 16 plus all of that divided by 9.8, and that will give you the time of flight. The total distance travelled. Just be careful here. Just work out the distance to the highest point. Okay, so just work out the distance to the highest point. So for that one, you're just going v squared is equal to u squared plus 2as. That's all you're doing. So you know at the highest point v is 0 because it stops, doesn't it, and then comes down. So the velocity is 0 at that point. We always have that. So 16 squared plus 2 times minus 9.8 times s. So it's minus 19.6 again, so take all that over to the other side and you've got 19.6 s is equal to 16 squared, so s is equal to 16 squared divided by 19.6, and that is the highest point, isn't it? That's when the velocity is 0. So you work that out. I'll just do that. So 16 squared divided by 19.6, and that tells me it's 13. I'm going to leave that on my calculator, but that is 13.06. Now that's the distance it's travelled to reach to the top, so it's double that to reach to ground level again, not ground level, but s equals 0 level, and then another 3 meters. That's the total distance travelled. So it's 2 lots of that up that. This point is 13.06 meters above the ground, down 13.06 meters to reach the level where it started, and then another 3 to hit the floor because it was on a raised deck of 3 meters, wasn't it? So 2 times that times 2 plus 3, and it gives us 29.1. So total distance travel is equal to 29.1 meters altogether for that one. Okay, so that was number wasn't number 7, that was number 9. Okay. There we go. Number 11. Number 10, actually, I did make a note of number 10. That's the only one I didn't do, because number 10 is actually the same as the one that it's almost identical to the one in the actual lesson. Number 11, well, it's a bit of algebra in here, but it's just to make it look confusing, but actually the maths is easy. A particle is projected vertically upwards from a point O with a speed of u meters per second. 2 seconds later, it's still travelling upwards the speed of a third of u, find the value of u, blah, 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 blah. Okay, there we go. So point O, that's here, and it goes up and it's down. And it's saying that at this thing, the speed is u, okay, at the bottom. And then after 2 seconds, so t is equal to 2, the speed here, that's the velocity, is a third of u. Okay, so it's a third of the speed that it takes off after 2 seconds. Find the value of u. So let's find the value of u. So if we say a, if we just use v equals u plus at, okay, we know up is positive, so acceleration is minus 9.8. The velocity at this point is a third of u, when the initial velocity was u minus 9.8 times 2. Okay, minus 9.8 is the acceleration, t is 2, and then you can see we've got everything that we need. So I'm going to take that over there, so that is 2/3 u. So take a third u off both sides, and then I'm going to take that over to that side, so that's going to be 19.6 positive, and then times that by 3 and divide by 2. So 19.6 times 3 divided by 2 gives you 29.4 meters per second. That's what it was initially. And then number 11, it says the time from the instant the particle leaves O to it returns to O. So that same old question, isn't it? It's just going s equals u t plus a half a t squared. What is this point here? It's s equals 0. Okay, it's 0 displacement from the floor, so we can put that into there. Initial velocity was well, we've got that now, 29.4, so 29.4 t minus 4.9 t squared. That I've done the half of the minus 9.8, and that just factorizes. Okay, so you just take out your t and you get 29.4 minus 4.9 t. So t is 0, that's where it starts. Okay, and 29.4 minus 4.9 t is also equal to 0. This bracket is equal to 0. Just factorising, simple, isn't it? So 4.9 t is equal to 29.4, and divide both sides by 4.9. So 29.4 divided by 4.9. That's the time of flight, whatever that works out to be. Okay, and that's number 11. I put 10 there, didn't I? But I meant number 11. Okay. So that's that, and then I'm going to do, rather than do 13 for you, I'm going to do 12 instead. 13 looks okay actually, but message me if you get stuck on 13, and I'll do that one and send you a private link for it. But I'll just do 12. So this is, you sometimes get these questions, they're sort of considered the hardest of them, and I've just sort of done this one. I did think about it, I'll be honest with you, for a moment. Just go through my notes, make sure I've got the, oh yeah, I didn't finish it off, but I'll put it down there. So this is one of those ones where a stone, someone's on the top of a tower. Let's do the question. There it is. There's a tower. Someone's on the top of the tower, and the top of the tower is labelled A, and the bottom of the tower is B, and someone throws a ball down, someone throws a ball up, and the balls collide in the middle, and you've got to work out, you know, the time of collision, or, you know, how far it is they travel before they hit each other. Okay, so let's solve this one. So let's have a look at the question. This question, well, it's not that. Okay, a ball is thrown vertically downwards from A, so u is equal to 5 meters per second here, going down. From the top of the tower block, this is 46 meters. Ooh, 46 meters. This tower block gives us that. At the same time, A is thrown down, a ball is thrown vertically upwards, and u is equal to 18 meters per second to the minus 1. Okay, the balls collide. Find the distance at the point where the distance from A where the balls collide. Okay, so let's have a look what's happening here. First of all, this ball is thrown and it's here, and this one has gone up. Okay, and it's gone there, and they hit at this point here. Okay, now what it wants us to find is it wants us to find the distance from A. So let's call that distance S. So this is travelling up to here. This distance, of course, is 46 minus S, isn't it? So let's get an expression for this. That distance is, there's 46, take away the S, that's at 0.46 minus S. Okay, now let's consider both of these. This one, for this one, if we want to find that distance there that it's travelling down, we can go down is positive for this one. So this is for A, and we can say that S is equal to UT plus a half AT squared. We can do that. And we can say that S is equal to 5T plus 4.9, and it's a positive distance. Okay, so it's accelerating down, so we can put plus 4.9 T squared. So that's an expression for that distance there. That's fair enough. If we did it for B though, okay, that is decelerating down. So as that moves up, okay, it's slowing down by minus 9.8. So we've got to be careful with this one. The distance it's travelled to there, okay, is 46 minus S. So we've got 46 minus S, that's that distance, okay, is equal to UT plus a half AT squared. Does that fit on your screen? Yes, it does. So, but this one we're going to go 46 minus S is equal to 18T minus 4.9 T squared. Now remember, in both of these equations I use this one because S now is the same. It's the same value of S in both of my expressions here. It's also, if they collide when they're both launched at the same time, T is the same in both of these equations. So it's about solving these two simultaneous equations, isn't it? Let's rearrange this. If we take the S over to that side and everything over to this side, we've got S becomes positive, doesn't it? And then we've got a plus 4.9 T squared minus 18T, and we've got a plus 46 there. Okay, so we've rearranged that and we've got that one there. Okay, so it's not an easy question. Now S is the same, isn't it? The S there is the same as the S there, so I can put those S's equal. So I can go 5T plus 4.9T squared is equal to 4.9 T squared. And already I'm looking at this and I'm thinking, great, because actually they've both got a 4.9 T squared on both sides, and I can simply take that off. And when I take that off, I'm left with 5T is equal to minus 18T plus 46. And I'm just looking at that now. When I add 18 to both sides, I get 23T is equal to 46. Now if I got that on an exam, I know that I'm right, because what are the chances of that? Divide both sides by 23 and you get T is 2 seconds. Okay, so they collide after 2 seconds. Now it doesn't matter whether you put 2 into this equation or this equation, it's going to give you the same value of S. So I'm obviously going to go with this equation. S is equal to 5 times 2 plus 4.9 times 2 squared. So S is going to be 10. 4.9 times 2 squared. So 4.9, 9.8, 19.6, 19.6. So they collide at 29.6 meters. Now that 29.6 meters, remember, is from A, so it's down 29.6 meters. They collide 29, and it seems strange that you haven't done it from floor level. Well, we haven't done it from floor level because the question hasn't asked that. Okay, the question asked for it from A. If it said from the floor, we would have called that S, and this one here would have been 46 minus S, and 46 minus S would have gone in this one, not in that one there. Okay, so that is number 12. And I think that's enough. I could do 13, but I'm going to let you have... Oh, should I do 13? No, I'll let you have a go at that one. Okay, otherwise I'm doing too many. So do the odd ones first, so you're going through those so you get them all, because it is a mixture of ones coming down and ones going up. Do the odd ones first, and then do all of the even ones, and message me if you get any problems with those. Okay, thank you. Bye-bye.